Hey everyone, thanks for joining the webinar today with Temporal and Dust. My name is Chris Kilkoff, and I'm here with Stan Polu, the co-founder and lead engineer from Dust. Stan, you want to say hi?
Hi, everyone. Super glad to be here. Thank you, Chris, for having me.
Yeah, we're really excited for this conversation today to talk about how Dust builds their agents with Temporal. Brief introduction to myself. So I'm Chris. I am on the go-to-market team here at Temporal Cloud. I have been at Temporal for about 2 years now. And before Temporal, I spent some time in the database world over at MongoDB, and I'm based in Washington, DC. And I'm joined by Stan today. Stan, would you want to do a quick intro to yourself?
Yeah, sure. So I'm an engineer, studied in France and in the US, started a company, got acquired by Stripe, spent a bit of time at Stripe from 180 people to 3,000. So it was a kind of a fun ride. Then move on to interesting myself in AI. And so got the chance to work at OpenAI for 3 years doing research. And in 2022, wanted to do more product. And so that's how I started working on Dust, which is what we're focusing on today.
Awesome. Thanks, Stan. I definitely want to dive more into your background.
Yeah.
Um, I think we could probably spend the entire webinar talking about that. So I'll definitely hold myself to some time there. But just for a quick intro of what Dust is. So Dust, as Stan mentioned, they're a Paris-based AI data platform company that helps organizations build context-aware agents that integrate directly with your tools. So like think Notion, Slack, Google Drive. And like an example use case is, let's say you have a Dust agent that a non-technical person like myself can build. It will scan all of my Slack messages, the channels that I'm in, and then at the end of the week, it'll create like a summary for me and say, hey, this was the topics you covered. This is a priority. Maybe there's like things for ARR to build like charts and graphs. And so Dust goes beyond just general purpose models like ChatGPT because they're built for the enterprise to enable teams to complete complex tasks across sales teams, support, engineering, and much more without needing to write code. And they use Temporal Cloud for the orchestration layer for those agents. And Dust works with really nimble startups that are doing well, like Clay, which is a sales company. And then they work with larger companies in Europe, like Allen, who do healthcare, and Quanto that does finance. But that's a quick like intro to Dust, who they are, what they do. Stan, do you want to check me there on anything or add any
No, I think it's
context?
perfect. I think the way we split the market of agents is really you've got the agents that operate in a vacuum, which is more of a B2C setup. It's a vast vacuum because they have access to the internet, but you have the person interacting with the agent. Then you've got agents operating inside of products. That's really the whole realm of AI verticalized companies and also incumbents adding agents capabilities inside of their own products. And I think the scope that we want to focus on are agents that operate across products. And so in that sense, you create an agent, you give it capabilities to interact with different products, be it Slack or Salesforce or GitHub, etc. And they appear much more like a coworker because they have access to all of those products and they are pretty horizontal and they can cover workflows that and stuff that you do on a day-to-day basis that can be automatized. So that's kind of how we kind of split the agent space as of today.
Okay, awesome. Thanks for clarifying that. And so for today's conversation, this is our agenda. Once again, I want to learn more about Stan. Awesome background. Touch on the engineering culture at Dust and how that shapes the product. Review Temporal, right? Why they chose Temporal, why they use Temporal Cloud, what's new on the roadmap with Temporal and Dust. It's an opportunity also like to feature requests, things like that, and then dive into the architecture of Dust and review some real world examples and do some Q&A. Does that sound good for you, Stan?
That's great.
Awesome. Let's go back there. Cool. So Stan, your background is like really fascinating, and honestly, that's like my favorite part of working at Temporal Cloud is I work with startups like you, and every single day I get to talk to these founders who are leaving cushy jobs, or maybe it was not cushy back then, but maybe it's now like OpenAI and going against the grain, building their own thing. And every single call that I come into, whether it's people who are really busy like you and I might just get 15 or 20 minutes, it's they have this energy that's awesome and I really love that. And so could you just give me an overview of what your journey to build Dust has been like. You're from France, you went to Purdue, Stanford, you went to Oracle, and you built a startup at Oracle. You got acquired by Stripe. You worked at Apple, then a little company called OpenAI, working with Sam Altman, Greg Brockman, Ilya Sutskever, just amazing people to work with. And then you're one of the first people who left OpenAI, like an alumni, and you started your own business. Can you just like talk me through that a little bit?
Yeah, sure. So I think it all started by mostly building up that first company with my current co-founder. So we started the company together something like 15 years ago. We were fresh out of school and started a company in Paris. And we made every mistake that can make on the book, I think, learned a ton. We pivoted a gazillion time, and we eventually found something that kind of worked on Instagram analytics. It was at the time when Instagram was being bought by Facebook, so pretty early, even in the arc of Instagram itself. And we addressed a nice niche of 1 to 2 million ARR, but maybe because of the market, probably because of us, we didn't find a way to really inject more growth into the business. And so after a year or two of being somewhat flat, we kind of tried to find an exit for the company that was nice, and that's how we ended up at Stripe. And we were actually Stripe among Stripe first acquisitions. It got close to not work because they were like, oh, we really love you guys, but you're a European company, so it's complicated, etc. But eventually it worked, so that's great. And got really lucky to work at Stripe. Joined, there were 150 people, I think, when we joined. And we
Wow.
stayed there, both Gabriel and I, for 5 years, up to 3,000, I guess, people. So it was kind of a fantastic experience of the scale, hyperscale for an organization and for a company. I think the learning at Stripe is really what scales looks like. You build your own business, you have growth, you're excited. At Stripe, it was really like that during those 5 years. It's like you look at the amount of the main metric for payments is TPV, so transaction processing volume. The thing was just skyrocketing, and so that's was really fascinating to see how Stripe got constructed around that traction. Eventually, at the end of Stripe, I started interesting myself in AI again. Again, is a really big board because I had studied, I had taken like a Andrew Ng class at Stanford. It was pre-deep learning, so we were mostly doing half features for vision and A-star algorithm for search. And I started digging into it again, and I wanted to find something. It was at the time of the Atari games movement. So post AlphaGo, a lot of reinforcement learning being done on Atari games and such. And we really wanted to dig into something that had a bit more of a societal impact than games. And so that's how I landed on trying to mess with AI and math. And at the time, I knew Greg Brockman from my time at Stripe. I'd worked with him, got to know Elias through Greg. And they just had finished the Dota project, where they managed to beat humans at Dota 5 against 5, if I'm right, Dota 5. Anyway, and they were starting a reasoning team, and so that's how I eventually found my way to OpenAI and did research there. I'm not a trained researcher, so I really tried to do my best for those 3 years. And I did research on applying and exploring the mathematical reasoning capabilities of LLMs. In the context of math, and in particular in the context of formal mathematics. So formal mathematics is a setup where the proofs are programs, and you have a type system that can check them. So you have something that is great, which is perfect verification. And so that's a great way to explore the capabilities of the models that are very creative but make a lot of mistakes with a system that can actually verify the predictions at scale. To really dig into the capability of those models to learn and to learn from them or from their own discovery. Anyway, fast forward 3 years, it's the end of 2022. GPT-4 was just finished training, I think in June, if I'm correct. GPT-4 gets released much longer after that by OpenAI, I think more like in January or February of 2023. And so I wanted to go back to products. I was convinced that technology would have like massive impact in society, and yet the revenue of OpenAI, which is kind of the most direct metric of the impact on society, I guess, was still very, very low. I think at the time it was in the tens of millions or something like that. And so the original hypothesis for starting working on this was, well, that technology is absolutely fantastic. And so yet it's not yet deployed at scale. And so there's probably a lot to do at the product layer, a lot to do to make it more accessible to maybe developers, users, whatever it is, but really explore the product layer. And as it happens, ChatGPT comes through there a few months after, which kind of strongly confirms the hypothesis, because ChatGPT is mostly a product layer on top of what existed already, and kind of triggers that whole movement around GenAI. And so managed to convince Gabriel, my former co-founder, to join me again, and we incorporate Dust in something like February 2023. We raised some money with Sequoia, and we decided to focus on internal productivity for companies. And so that's kind of the starting point, the real starting point for Dust as it is today.
Awesome. That's a really exciting background. I loved going from like Atari and like working on games. And you keep like coming back to like making an impact. And is that like where like maybe starting a company comes from, and like kind of your founder mode of like wanting to change the world a little bit, or where did that come from?
Yeah, there's a bit of that. The funny motivation, which is not the only one, but one that is funny, so I'll share it, is that if you believe that AGI is eventually coming, it's kind of the last train before you can start a company. After that, it's going to
Okay.
be computers all the way down. And so it was kind of the motivation. Okay, guys, if you want to do a company again, it's probably no, because in 5 years or 10 years, it's going to be done. There won't be any company to create anymore. I mean, it's a bit of an exaggeration, but I think it's there's part of that as well.
Awesome. That's really great. So it sounds like you, and in essence, like just you got like a PhD in research at OpenAI, but you didn't have that background too.
Yeah, I
Is
mean,
that
it was my time at OpenAI is definitely the way I see it is a hidden PhD. It's looks like a PhD, but it's not a PhD. I didn't get any diploma out of it, but I had applied when I finished Stanford. I had applied for a PhD. Decided eventually to not go for a PhD, but go work for Oracle, which was a very weird decision at the time because at that very same time, Facebook was probably 200 people at the end of the streets. Twitter was probably 10 people in SF. And out of all those crazy and exploding company, I decided to go to Oracle, which is the weirdest decision that you can make. But then I always longed for research a little bit, and so my time at OpenAI was kind of a way to really serve as a way to explore that.
awesome? Well, thanks for that background. That's honestly really inspiring, and I'm sure we'll touch on a little bit more of that background, how it shapes your engineering culture at Dust shortly here. But I want to just transition into like how Dust changes how people work. Um, Do you think you can give me like an overview of maybe I touched on a brief example when we did the introductions of like, okay, scanning like your Slack and giving you an overview of what you worked on at the end of the week. But can you provide me some more examples on like where Dust like makes a meaningful difference for like a user or a team or a business?
So I think we don't necessarily have a specific use cases. Use case agents are extremely versatile, and they can do a bunch of stuff. And so the reality is that when you think about the way companies operate, they have workflows, so way of doing stuff that are kind of somewhat similar from a company to another, but kind of also in a very specific ways different from a company to another. And so we really believe in that kind of a horizontal approach of providing to every employee the capability of building agents and exploring use cases that they have locally to try to accelerate their work. The use case at which we shine is actually not necessarily a specific use case. It's the use case of giving the keys to the leaves of the organization to explore creating agents and explore using them on their day-to-day basis. And the way it kind of transcribed as a metric to us is that we have. So the nice thing about working with Sequoia is that they have very high, and Temporal is also a Sequoia company, by the way, I think. They
Yep.
have extremely high comparables, meaning that when you come back after months and you've had a crazy growth and you're super excited, they tell you, yeah, not bad, top 30 percentile of the top companies we have, you can do better. And there's one metric on which we really shine, and we are kind of the top 10% of every company they have today, is expansion. we expand really well into our accounts. And the reason why is because our use case is really to giving the ability to the people to build for themselves stuff. And so that kind of propagates organically within the company. Some tinkerers at one end of the company start exploring something, it starts working, the team starts using it, then people see that usage through Slack or GitHub or stuff, and then all of a sudden there's kind of that adoption of building agents for your use case that happens within the company. And I think that's what we're mostly excited about. If we try to go one step forward, so I'm going a bit meta, but then you stop me if I'm providing too many tokens. But if you think about the funny part about the environment we're operating in most companies and AI companies in particular is that if you think about the past 20 years, the technological substrate that we were operating on to build companies was extremely stable. It was basically PostgreSQL and JavaScript. I mean, I'm again exaggerating, but you get the point. And today we are operating on a technological substrate that changes very rapidly and very dramatically. Not even at the month level, but even on a weekly basis, you have new capabilities that emerge, new ways of doing stuff. And so it's really interesting exercise to build a company in that environment. And what it means is that it's almost impossible to paint a clear vision of what your product going to look like in a year. The reason why is because you don't know where the technology will be in a year. If you look back 1 year before, you see that the technology has fundamentally changed, and you would have not been able to predict your product of today 1 year ago because the technology you use has changed dramatically. And so you have that kind of fog of AI in terms of product vision. That is kind of an interesting bit because you have to learn as an organization to navigate a little bit blind on where you are going. But the very high level vision for Dust is we really want to be the helmet or the HUD that employees put on in the morning, and when they have that kind of a cockpit, they see people interacting with agents interacting with other agents. They see all of that happening within the company. If they remove if they get out of that cockpit, they just see the humans, and they have a kind of a very limited view of what's really happening because a lot of the work has been kind of delegated to agents. And so building that really great cockpit for people to equip themselves and execute and operate agents to accelerate their work as a team or as a person is really what we're after.
Yeah, yeah. So it sounds like it's less of, hey, this is a perfect use case for Dust. It's more of how do we empower people to just build things and get creative. And it's like you're saying, we don't know where the future of AI is going to go,
Yep.
so we can empower people to create that themselves and create their own agents and build the workflows that they need in their day. And so that's where I know you've mentioned in different blogs and resources out there that you prefer like the bottom up adoption of like getting Dust in the hands of individual contributors to build what they need to automate in tasks in their daily life instead of like going to a CTO or head of a business or head of finance or whatever and saying, hey, make all of your employees use this, like buy all these seats. You're saying, hey, once people get this in their hands and see how powerful these agents can be, like that's the best way we're going to grow.
And to be honest, though, our product has to be really great, but the power doesn't come from our product. The power comes from those models that are absolutely incredibly powerful. And so the point is that to make them really useful, you have to not only have a very nice product interface for humans to agents, and there's many questions there, but you also have to do a lot of plumbing to bring the context in from the company to those agents and bring the capability for taking actions. And so part of our job is also a ton of plumbing.
Yeah, no, that's awesome. Yeah, I've heard like some companies have even like an 80% adoption of Dust, like using Dust at their business, which is pretty incredible.
Yeah, so enterprise for us is a small enterprise. It's more than 300 people, and on all of our enterprise, and it's a true metric. All of our enterprise users, and we have between 20 or 30 of them, I guess, something like that. They all above 70% monthly active employee, which is crazy.
Wow.
It means that in every enterprise client we have, basically mostly everybody uses us at least once a month.
Awesome. That's really great. So I want to touch on like the engineering culture because that's something else you call out. It's like not only do you empower like maybe end users of Dust like myself, but you also empower your engineers to be directly responsible individual for like product initiatives. Can
Yep.
you talk to like that engineering culture and what it's like to be like an individual contributor engineer and like feedback into the product?
Yeah. So the way we operate is that we give a ton of responsibility to engineers. I mean, we can do it because we're still small. We're not married to the idea of not having product manager, but it's just a state of affair right now. And we're really looking for and trying to nurture the culture of having engineers that can do products. And what it means for us is that we try to have a very simple stack rank of the projects we want to work on. And a project is something kind of chunky. Let's say from a week or two of human work, 1 or 2 human week work to something like 1 or 2 human months work. And so the idea is to have just a couple of those projects prioritized at the same time, so that we don't fall into the trap of having everybody working on different stuff. And instead, people kind of engineers flock to those projects, and we kind of meet on those projects as engineers. And so each of those projects have what we call, and that what is called in many places, a DRI. And that DRI is an engineer and is in charge of the entire lifetime of the or life cycle of that project. And so that means being in charge of making the discovery with our users, being in charge of really understanding what we're going to build, being in charge of designing the solution, and being in charge of during the build phase of being the quarterback of building the thing and actually writing the code. And when the project is mostly done, being in charge of making sure that we communicate well what we've done with our users. That doesn't mean that that DRI has to do all of that. It means that that person is responsible for making sure that it happens. And so that's really a big chunk of what product management is, into some extent. And so that's something we've been nurturing and we're pushing for. It's tough because not every engineer actually enjoyed necessarily doing that. Some engineers like it more than others, and the way we decide who is a DRI is kind of a quite organic. It's like generally we're a team of 20 engineers. It's a small team, and so very naturally people gravitate to some projects and become naturally a DRI. So that's kind of how we operate so far. It's gonna probably break in really bad ways pretty soon as we grow the team, but so far so good. That's what we've been doing.
Well, I'm glad it's working right now, and it sounds like to be an engineer, it does you might need to have that own like founder's mindset of yourself and be like, hey, I want to take on more responsibility. I want to run like learning the product. I want to know who's like talking to the customers to get direct
Yep.
feedback. So that's really exciting to hear about the culture that you're building there. And even in today with AI worlds, you can have really small, nimble teams that will scale
Yep.
to a lot of revenue. So I'm sure Dust is on that path. One other question I wanted to ask you is just touching on like the open source model of Dust. So Temporal also, we're an open source product, MIT license, but not only like are we an open source product, but like we have an open source culture, and that like starts down with like our co-founders' commitment to our open source model, community, and that breathes like through our employees. So could you talk to me just a little bit about like Dust's role in the open source
Yep.
community and how that impacts the culture?
So we are extremely different. We're extremely different because we are actually open source, and all of Dust code, except for maybe one repo which is called Dust Infra, that has our kind of a Terraform infra in it. All of the code of Dust is MIT licensed on the internet, and we're not doing it to have necessarily a strong commitment to open source, or we're not doing it to have an open source strategy, as is to some extent the strategy of Temporal, and which is one that works really well. We kind of do it because we can, and from the belief that the value of a code base is really the number of eyeballs that are really interested into making that code base great. And so we consider that somebody taking our code base and starting a clone of Dust is kind of a very low probability thing. And even if they did it, they would have close to zero chance of competing with us just by the nature of the situation. And so that's why we kind of like being on open source for that. The added value
Yeah.
of being open source is actually there are a lot of added values. The first is transparency with our users. it's really great to be able to pinpoint the bug in the code source to a user to say, when they are technical, to say, oh yeah, we see what's happening, it's there. Here's the issue, here's the pull request, here is the deployment of that fix. And it's also great because it's kind of a very nice forcing function for engineers to do things well. We have an operating principle that we inherited from Stripe. It comes from Stripe, which is called the front page test, which is really try to, whenever you're doing something, you want to do it in such a way that if it made the front page of a newspaper, you would feel cool about it. And I think being open source for us is kind of the front test page of engineering. It means that whatever we do, we're good with it being public.
Yeah, and I kind of think it ties back to like an impact perspective of what you've said earlier, is that the more eyeballs are, the better. So the more people looking at your code and contributing to it, and it's not about your open source code, it's about the engineers that you have working with it. So I love to hear
And
that.
to extend some users, there is also side value. Side value, we're not directly running an open source strategy, but with users that are really engaged, they actually contribute to our code base as well at times, which is great, which is really awesome.
Yeah, really love to see that. So now I would like to move to more of Temporal, review like why you chose Temporal. And then also for everyone on the webinar, if you have questions, please feel free to throw them in the chat. We can definitely field those at the end. But I guess a good frame of reference to start about like Temporal. And we were talking about this while we were hanging out in the weight room of like how what's Dust's first iteration like, maybe it was similar to an orchestrator, but even before that, like how do you, when you're looking for software and building stuff, how do you think about, oh, should I build this myself or should I buy it off the shelf from somewhere else?
I think the answer to that is pretty yeah. I mean, it's a tough question. The build versus buy is a tough question. Being a VC backed company, you have to be realistic that whenever you can buy speed, you should buy speed, right? And so it's a question of what are the parts that are strategic to you versus the ones that are not, and the ones that are not, or the ones that are very well controlled and understood, you want to buy them versus building them. And so when we started exploring, so our use of Temporal really started with our ingestion pipeline for all of the data we ingest for companies from their Slack channels, their Notion pages, their Google Drive. All of that are pretty complex ingestion workflows. And Temporal kind of really appeared as a perfect solution for that. Basically, what happens is like you receive a webhook from Slack. What you have to do is you have to check the webhook, and then you have to go back to Slack, ask for the thread, and then once you get the thread, you have to chunk it, and then you have to embed it with a model, and then once you've embedded it, you have to ingest it in your own database and vector database, and then once you've done all that, you're kind of done with that processing that webhook. And there is many chances that process is actually pretty long. It involves running LLMs for the embedding, and so there's many chances that it might fail. And so that's really the reason why we went with Temporal, is the ability to model those kind of somewhat complex workflows through activities, and have each of those activities being built in an idempotent way, and be able to therefore acknowledge a webhook instantaneously because we just queue the workflow inside of Temporal, and then know that we're good with that because Temporal will ensure that eventually that workflow will be processed. The incredibly high value use case here for us is that we ingest a ton of data. And so when we have production problem on our product, all of that ingestion goes through our actual public API. And so when we have problems of latencies or problem because there's something wrong and everything starts being slowed, we have that ability to just scale down the temporal workflows from that ingestion pipeline. And that still means that we'll still be receiving the webhooks, acknowledging them, and knowing that the workflows have been created. That means that they won't be processed right now, but it also means that we won't be losing any of that data. And so I think there on that ingestion use case, Temporal has been a really a godsend solution for us. And so that's where we started. No, more recently, there's a new emerging use case for Temporal for us, which is kind of super cool. basically an agent loop. Back in 2022, it was user message, agent message, user message, agent message. There was really no agentic loop. It was almost a sync interaction, pretty long because you have to generate the tokens, but mostly a few seconds to tens of seconds. That's fine. As the tools use emerge in 2023, in 2024, let's say, those agentic loops started being much longer. And in 2025, with the syncing paradigm emerging to push the capabilities of models, it's even longer. It means that between for each tool call in the agentic loop that you're running before doing an answer to the user, you have a long stream of syncing, then a tool used, then it comes back, a long stream of syncing, then a tool used, and it comes back. You can have probably a dozen or a few dozen that might add up to something like a minute, 5 minutes, or even 10 minutes. And in the case of deep research type interactions, more like 30 minutes. And no, the agentic loop that you had in 2022 that were running sync in your production servers doesn't cut it anymore, because they're getting longer and longer, and you're not deploying less often. And so as soon as you deploy, you kill eventually all your loops, right? You can
Okay.
have kind of a timeout for the deployment. Let's say I'm going to wait maybe 2 minutes for running that pod in QB, but you're not going to wait 30 minutes, because otherwise you would have deployments that would take hours. And so we are entering a world where the agents loop are longer and longer, and our deployments kind of start killing them in a way that is creating a level of errors for users that is not acceptable. And so that's why we're moving to using Temporal as well for the agent loop. And so that means that whenever the agent loop is started, we actually start a workflow, and each part of the agent loop is operated as an activity, and that makes us resilient to the deploys and provides a much better solution for our users, and makes it realistic to run agent loops that last for something like 10 minutes.
Okay, that's really exciting to hear that you're going to use temporal for that use case. So this kind of sounds like a deep research. That's the looping, right? Like it's just asking a complex question that goes out and like could
Yep.
take a long time to solve. And so basically your customers would just be sitting behind and like waiting to get this information. And
Yep.
then you mentioned there's a level of errors too. So like what would happen to a user if I'm doing like a big agentic loop with
Yeah, so
Dust
you,
and there's
you
an
have an
error?
agent, you ask it. Yeah, you have an agent, you ask it to, I don't know, prepare my board pack for the next board meeting. And it's a pretty crazy agent that does a ton of search in the product stuff, and does and all of the things we support. It does a ton of search in our product stuff to know what happened, do some Snowflake queries to get metrics, updated metrics, generate the visualizations, and then also go into your users, the communications you had with your users to try to extract quantitative information about what happened, whatever it is. And that agent might run for 10 minutes. And you start your agents, you're starting it, you know it's going to take 10 minutes. And so you're probably not going to stay in front of your screen. It's kind of funny to see the progress and look at what happens. But when you start trusting that agent, just fire it and go away. The problem is that within those 10 minutes we do a deploy, we're just going to kill that agent at some point. And so that means as a user that you come back 10 minutes after or 20 minutes after, and you're like, awesome, my bot pack is going to be ready. And all you see is that you've got an error in your agentic loop, and you can see what happened, and you see that it stopped at some point. It's extremely frustrating. And so that's exactly what we're trying to solve here.
Awesome. Well, that's really exciting. And I think you're speaking to really the value proposition of temporal. What we were always saying here is the velocity. So that's like the speed that you can go at, and which is why you guys decided to use temporal cloud. The reliability. So uptime, SLAs, having reliable
Yeah.
code that you know is not going to fail. And then what you're touching on now is the insights. So when something does fail, you can actually see what happened.
Yeah.
So are you looking forward to using temporal for that too? So like when you do have failures here, you can actually see where it's failing. Was that also
I
a
mean,
black box for you?
we're already using that a ton for the ingestion pipeline, and that's surely going to be one part of what we're going to be using for those for running those agent loops on top of Temporal, for sure.
Cool. That's exciting. So what were you like, did you start with temporal like greenfield when you were building Dust, or were you using something else before that?
No, I think so. Again, in the history of Dust and Temporal, we start with the ingestion part, so
Yep.
indexing old Slack of Notion, and I think the first line of code there was setting up Temporal.
Okay, awesome. Um, how has Temporal like influenced your thinking about just architecture in general? Like the other thing I love about my job is when I talk to people, they're like, "Oh my God, I found Temporal. Like this is like one of the best things ever. Like durable execution is amazing." And then to see that like in the marketplace and like Forrester reports and the Gartner quadrants of durable execution, it's really exciting for me. So like, how does like Temporal like influence how you think about just computer science in general?
To be honest, and I'm not trying to be the to make the advertisement of Temporal, but I think it's to me Temporal kind of opened a brave new world. It's because we were in a world where you had Kafka queues, which was the go-to solution in a sense, and you were like, okay, I need a queue system, etc. And I think that and that really that dichotomy between the workflow, which is actually written in code and so is kind of a fully universal in its expressibility, and the splits through activities kind of redefine the way we think about error handling, because really you can then really manage your errors at a very granular level and kind of reshape kind of our thinking around that. It's really felt when I started using Temporal. It probably was in end of 2022, beginning of 2023, I guess. Really felt like discovering a new way to do durable execution. I think the world you found as a way to market your product is just perfect. It's just what it is, and it does what it says.
That's awesome. That's really exciting to hear. So when was the first time you heard about Temporal? Did you hear about like Cadence, or was Temporal the first time that you heard about
I
us?
don't, I don't remember the details, but basically at the time we say, okay, we want to create data sources that are connected. We want to ingest. Okay, we need some form of a queue system to do that, and we just explored the market, and we landed on Temporal and another one, but to be honest, I don't even remember the name. And it felt like a natural choice to go there. It was 2 years ago, and so I missed the details, but we really haven't regretted that decision.
Okay, that's awesome. And we do have a question in the
Yeah,
chat from
it's a really good
Nuno.
one.
Did you see that one? Do you want
Yeah,
to
yeah, I've
just,
seen it.
I'll read it out. So if your calls to the LLM are a temporal activity, if so, how did you achieve real-time streaming back to the browser?
Yeah. So even today, you actually have to solve that problem before even moving to a durable execution kind of setup for agentic loop. Why you have to solve that problem? Even if your loop runs things in your server, you have one pod that has been asked to run that agent loop. So the user connects to that pod. Through QB, you've got multiple pods, load balancer across your pods. That pod starts running the agent loop, and another user or the same user by refreshing might land on a different pod for querying and knowing what's the state of that agent loop. And so you need to be able to stream those events, which is not only the tokens, but also the fact that the model decided to use a tool, the results of the tool, the fact that there's a response. All of that is kind of a pretty complex set of events. And you have to be able to route those events back to the user, even if they're connecting through a different pod. And so that means that even if you're not using durable execution in any way, you do have to have kind of a system for being able to retrieve and stream those events from any pods. And so that what we build here is that we're using quite naturally Redis, which means that when we have an agent loop running, we've got a Redis channel where we put those events, and we're capable of retrieving those events from any pod at any time. And so moving to Temporal will be exactly the same. That means that we're moving all of the execution and interaction with the model inside of activities running on workers that are not part of our kind of a main deployment. But then those activities will be streaming those events back to the same Redis. And so that means that from an interaction with the client side, it's going to be almost transparent compared to what we have today.
Awesome. Thanks for that answer. Nuno, throw something else in the chat if you have a follow-up. But we do have another question from Tom, which I think is a great one. If you think back to your life before Temporal when you're developing, like what was like your biggest pain point for you that's solved by Temporal?
To be honest, I don't have a very crisp answer to the question, because I at OpenAI I was doing mostly research, and so didn't kind of run into those kind of stuff. At Stripe, I was really working on the payment APIs and stuff. So everything was kind of synchronous by nature. we did. I mean, we did. So at Stripe, I was part of the ops team, which is the internal team in charge of making it's kind of the machine room of Stripe. It's where you actually move the money, and there's a lot of asynchronous stuff related to settlement files. So the way card networks work is that you aggregate authorizations all day long, and at the end of the day, you create a massive file which is the settlement file, and you're supposed to send it on time to your bank, to your acquiring bank, to get the money in exchange. And so there, I think we had at the time many issues with the fact that you start the process of building a settlement file. It takes minutes, if not hours, because there's a lot of transactions in there. And for some reason, because there's a weird field with a weird emoji in it, in a place where we didn't anticipate it, the entire file fails due to just one line not being processed correctly. And so I remember feeling that pain a lot at Stripe. And I think actually Stripe is starting using Temporal, I've heard. And so I don't know if they're using it for that, but that's probably a very good use case as an ex-Stripe. I can attest to that. And so that's where I see the kind of challenge that Temporal really solves. It's when you have a pretty long-lived process made of many small sub-processes that are failable in a sense, and where they are easy to retry. And so that's really where it shines. And that's true of ingesting data from those platforms. That's true of an agentic loop in the days of 2025, where they started being pretty long.
Awesome. Thanks for answering that, Stan. Tom, if you have any other questions, please jump in the Slack. Yeah, it's really great to hear about like just buying into durable execution. I know when our CTO and co-founder Maxime was in Paris, you guys met and had a little meeting there. So I'm sure it's like meeting Max, his energy that he brings to temporal and durable execution is next level. And you definitely have that too for Dust and agents. The last question I had before we switch more to the architecture and the technical questions with Temporal is, so Temporal is open source as well. What made you want to use Temporal Cloud from the beginning and not self-host Temporal and take on all that complexity?
Yeah, I mean, we touched on that. It's the typical buy versus build. At the moment, we decided to use Temporal because it was seemed to us to be a very powerful system that matched exactly what we needed. It was very crystal to us that we would want to buy Temporal Cloud instead of managing the deployment and the operation of a Temporal Cloud service inside of our infrastructure. And so I think it's for us, it's it's really a typical, by buying we go faster, so let's just buy, and that's has been the true reason why we went with Temporal Code. And I think it's without regrets, because at the end of the day, the part of Temporal that operates in Temporal Cloud is the one where you want maximal reliability, because that's all of the durable execution nature of Temporal relies on the reliability of the I don't know if you call that the temporal orchestrator or whatnot. I don't know what's the technical term for that part, but that's really it's been really great to rely on Temporal on reliability for that part, and being able to be much more nimble in the way we orchestrate our workers, because you know that whatever you do in those workers is retriable, and so you can be more aggressive in the way you deploy them and maintain them, which saves you time.
Awesome. Yeah, it goes back to that velocity buy versus build model. And thanks for doubling down on that. So I want to transition now to the technical portion, review architecture diagram, questions that we have. One thing that stuck out to me is that Dust prefers like smaller, more nimble, specialized agents instead of just like one general agent. And so you don't have like a one tool fits all approach. If you could walk me through maybe this architecture diagram as it relates to temporal, and like touch on like, okay, how you guys are just using more smaller, nimble agents instead of one large agent, that would be great.
Yeah. So I mean, sorry, by agents, which agents are you talking about?
I would say you Instead of having like general agents, you have more
Yeah.
specialized agents.
Yeah, in a sense, so in a sense, the whole point. So I'll answer that kind of a meta question and then dive into that diagram, which is super interesting and weirdly accurate. I know we've worked together on it to some extent, but it feels weirdly accurate and very precise. So that's great. And so. Basically, the two hypotheses, the two early hypotheses of Dust are: if we want to do anything about internal productivity for people inside of companies, we have to have context on the company. If you don't have context on the company, there's a lot of stuff that you won't be able to do. Yes, you'll be able to translate stuff. Yes, you'll be able to do good suggestions based on a small question. But you're not going to be able to answer questions about what happened last week. You're not going to be able to answer questions about what are in those run books for engineering. You're not going to be able to answer questions on what are the latest numbers coming from your Snowflake data lake. And so it was clear to us that we needed to build the pipes to get access to that context. And so once you start doing that, people start pushing to you a ton of context. It's like all your Slack threads, all the Notion, all the Google Drive. And that data is extremely rich, but also extremely noisy. And so that means that if we had just a global agent that does it all, well, we've seen and we've tried it that it just doesn't work. It doesn't work because the context of a company is pretty large. The retrieval is never perfect, whatever it is. The agents themselves are not perfect. And so if you have a very specific use case, it's just going to fail pretty badly in most of the time. It's going to work well for a very large type of search question. If you're asking, what is this or what is that, yes, it's going to work well. But if you're asking about covering a very specific workflow, it's just going to lose itself into all of the data and all of the tools that it has access to. And so that's the reason why the second hypothesis of Dust was really to not have one global agent, but have the ability to create custom agent, because you solve the kind of accuracy problem by creating a product surface that incentivizes your users to do the hard work of selecting the data and selecting the tools. It's not the hard work, it's the very hard work for us. It's a pretty easy work for the user because they know exactly what they want to do. And so they know exactly where that data lives. And so that's the idea around custom agent. It's creating a product surface so that people, when they have a specific use case, they select exactly the data that they know is required for that use case. They select exactly the tools they know that are required for that use case and nothing more. And so mechanically, you get much better results. And so that's kind of the motivation for kind of a nimble custom agents. And once you start building that fleet of nimble custom agents, that's where it gets fun, because you can start creating higher order agents that are meta agents that call agents that have been specialized on some use cases. And all of a sudden you can recreate those kind of global agents that know to do pretty much everything, but through the use of more smaller and more nimble, more focused agents that have been created and are being created by the team. So that's kind of the story around all of that. And so the first part was we need access to the data. And so that's pretty much the architecture of what we've been using and that we covered a little bit earlier is we have that connector service that has basically an API to receive webhooks. Sometimes it's webhooks, sometimes it's kind of you're pulling the APIs of those platforms. But let's say a webhook, whenever we receive a webhook, the first thing that happens is that we kick off the temporal client and we queue a workspace, we queue a workflow inside of the temporal service. And so that goes to that purple box. And so there, the workflow starts working. And so as I described, for each platform, the workflow is going to be slightly different because you need to do this and that to retrieve the information, and maybe you need to embed that in that manner. And so all of those operations, part of that workflow, are cut into activities that get executed inside of our connector service through deployments that are workers to actually run those activities. And so those activities means fetching the data from those external APIs, that green box, and then eventually unqueuing the upset on our own API, what we call front, which is our product basically, and also obviously storing some state about the data that has been received and where we at in the synchronization of that platform. And so all of that happen inside of a temporal workflows and activities inside of that connector service. So basically, our connector service is a very thin layer of API exposed to the internet for receiving webhooks. And then everything else in that service is basically temporal workflows and activities. And so if we look at what's happening then, the the upsetting of the data that has it been created by connectors inside of front is actually itself also a temporal workflow. This time it's a pretty slightly more basic workflow. It looks much more like a typical queue system, which is a way of doing that semi-asynchronously instead of doing that sync inside of our API, which can increase the load on your actually user-facing instances. That's pretty much it.
Awesome. That is really helpful there. If anyone has questions, technically, in the chat, please go ahead and throw them in there. One question I had is like, how do you guys handle like idempotency or like duplication of like webhooks that trigger temporal workflows?
Yeah, so the in that setup here for the ingestion part, the idempotency is actually pretty simple in the sense that whenever we ingest data, we use to some extent upset semantics. When you think about it, if you see a document being changed on Google Drive, the upset key is the internal ID of the Google Drive document. And so if you receive kind of a change and you start putting the information, etc., all of the idempotency is kind of maintained by the fact that we know that the target upset goes to an ID that on which we have upset semantics, which means that if we insert twice, it just gets the latest version. So I think on that part, it's pretty easy. The more interesting part is on the agentic loop part, because you have places where you can be idempotent and you have places where you cannot. The typical shape of an agentic loop workflow is the following. It's basically, you've got a loop, which is the agentic loop. And then you've got a first step, which is the planning step. And the planning step is when you query the LLM. Outside, I mean, that is an activity. So it goes to OpenAI or Anthropic or whatnot, query the LLM. The LLM comes back with, oh, I'm going to want to use that tool and that tool. And so all of that, in that activity, you kind of receive the response and store it in DB so that you have full context and you have full persistence of what happened during that interaction. And once the activity completes, you can return in the workflow, you can just return, am I done? Or do I have a number of tool calls to handle? And this activity can be made idempotent pretty easily because you know in which step you are in your agent loop. And so if at any point this activity fails, you can just retry it. It will increase the latency for the user, but that idempotency is pretty easy. But then you enter, you go off of that, and if you have some tool calls to handle, you start running activities for the handling of each of those tool calls, and there you have a problem because a tool call can be a search, in which case it's perfectly idempotent, but a tool call might be send an email, in which case it is mechanically not idempotent. And there is, in many of those platforms that you can connect to, there is no notion of idempotency. And so there, I think for the agentic loop, you have to accept that the tool call execution will never be idempotent. You can make it idempotent in some platforms. You'll never be able to make it idempotent in every platform. Most of the tool call interface today are through MCP, which is the kind of a growing standard for interactions. And MCP doesn't have any idempotency concept. It doesn't have an ID that can pass to identify in an idempotent way a query or a tool use that you make. So in a sense, we are at a stage today where the ecosystem through MCP and etc. hasn't kind of factored in yet the idempotency requirement.
Mm-hmm.
That will come up because everybody will run the same problem that we have of
Yeah.
having to run those loops in a durable way. And so that's interesting. There's probably, I mean, prediction from there is that there's probably going to be some idempotency interface popping up in MCP at some point.
Okay, awesome. Yeah, I think that also, thanks for digging deep in there. And I think that goes back to like we don't know what's going to happen with AI in the future, and we're all figuring out this live as we go. And we are coming up close to time here. So I have one more question that I want to ask from the chat. And that question is like, so based off your experience, if I'm like a new engineer in college, or maybe someone brings in Temporal to the business that I work at, what's your advice to someone new just starting out with Temporal?
I think there's no particular advice outside of keep your workflow simple.
Keep the workflow simple.
Keep your workflow simple because the only the biggest edge, and you're doing a lot of work around that at Temporal, but I think the biggest edge is the kind of fact that since the workflow is code and it can be any code, the state of the workflow is kind of a internal magic representation of where you at in that code. And if you deploy a new version of the code and that you were in a state that you cannot reconcile with the current state machine represented by that code, Temporal tells you you've got I don't remember the name of that error, which is the fun one, which is you've got an inconsistency error in your workflow or whatnot, and then you have to do a little dance to migrate your queues, etc. And so it is part of the system in a sense, and it makes sense that this error exists because it comes with all the benefits and comes as a trade-off with all the benefits of Temporal. And so one way to mitigate that as much is to really keep the workflows as simple as possible and make sure to sync your workflows in a way that are themselves very durable, where you'll be able to tweak the business logic inside of activities, which is virtually free, but make the workflows the most future-proof possible.
Awesome, Stan. I really appreciate that. It's a non-deterministic error, says Tom. Thank you, Tom.
Non-deterministic error. Here we go.
And honestly, the best way to, if you're an early engineer starting out with Temporal, one, use Temporal Cloud, sign up for Temporal Cloud. We're offering 1,000 free credits now to sign up for Temporal Cloud. We also have, if you're a startup programs with AWS and GCP. And I mentioned the Slack community that we have. Please join our Slack community. It's a great place to get questions, ask for help. And then if you do use Temporal Cloud, you also get access to solution architects that can help you do design and architecture diagrams like this. And we have support teams that have response SLAs to help you when your code is in production and shipping to production. So Stan, really thank you for your time. It was awesome to get to chat with you. I hope I can make it out to Paris and we can hang out in person next time. I wish I was there now for the French Open and the Champions League final last week to celebrate with you all. But it was really nice. Thank you for taking the time. I know how busy you are, and really thank you for the partnership.
It was a real pleasure, and go Temporal. We're big users and really enjoying it.
Go Temporal. That's a good note to end on. And for everyone on the Zoom, you'll get the deck, you'll get the recording, and thanks for joining. We'll see you in the Slack community.
Thank you. Bye-bye.